I arrived at CoronaWhy a few months ago, but I've been doing other stuff and outside of the project. And then I come back and they tell me that you were doing this, and that's kind of my specialization, like standardizing data science and machine learning prototypes. So
Oh,
it's something that I
beautiful.
wanted to have. So this is Alex. Don't take this as any kind of personal. I mean, I'm taking your file because it's the one I worked on, and
No,
I saw the original one, so I know how things are. Any of this is as a personal attack in any kind. Is just
no,
to
no problem.
illustrate and try to explain. Okay, let's see. So this is the Python file that is generated from this notebook. This is the master branch on the and up. Okay, sorry, because my I'm on the sofa and now it seems that my mouse what is eating so much memory. Out. This out. Okay, now should be it. Okay. How can I drag the menu of yeah, okay. This is even worse. Okay. So here is the original notebook. Sorry for the delay. Um, and here the thing is that the problem with notebooks, okay, is that is a good tool for data scientists who are not wise in computer science or programming to be able to get fast to results, but it comes with some problems because it obfuscates or directly hides some of the complexities and the abstractions that are required to make good software. Okay, so for example, this is one example. This is taken directly from the notebook that is running on Google Colab. There, you can Google Colab solves automatically all the dependencies that you put them, and if it doesn't, you can automatically install from the cell. But that makes that when you have your code that you extract from the notebook, your code doesn't have a separate part. You don't know what are the exact requirements because you don't have them separate. Okay, this is the pull request that I open. One of the first things that I make always is this is a tab. No, I should have the requirements. Oh, there is no why there is no requirements. Uh, well, there is the now I'm a little astonished because I thought that I uploaded that. No, it isn't. Yeah, no, there is no requirements. I didn't upload them, but I think that I have on my local. The thing is that here you don't know what you need to install. I mean, from the we need to understand that software can be used by different people wanting to do different things. It's not the same. For example, one data scientist that want to use your software to replicate the results that you claim to have obtained, that somebody who wants to extend functionality, let's say, oh, you have this nice model, I want to use it in my pipeline. That's somebody who just wants the results and is not interested at all in all the details of data science. So of the and the development. So the thing is that we here, for example, this is in this notebook, we can see that they have this is drive because this all this downloading of the file only works if you are on Google Colab and you have that file on your drive. So that means that is not replicable. Is not replicable. That so somebody came here and you want to run this on your local computer, you cannot. You want to run this on your Google Colab and you cannot. we need to differentiate what part of the code is the part of the real code, and what part of the code of the things that we have in the notebook are the ones that prepare the things that we have to work with our code, like for example, formatting our data, or connecting to external resources, or doing things like that. This is something that is important to have clear. I thought, let me, I cannot, okay. It is, I got, this is, it was, yeah. I don't know if in my local I have the, no, I don't have the requirements in a split. It says setup embeddings. Yeah, no, I don't have it here either. So this is a mistake. I'll tell you about that, but I didn't did it myself. But for example, on usually, let me show you other packages that we have work. When you are doing any kind of experiments, any kind of stuff, you want to have the which version of which package you have. So when somebody is gonna replicate your results, he knows that, okay, I need to install this exact version, so this is how I'm gonna make it work as, for example, this Stasia where I worked before. Here we have a setup py. This is on a different level. For example, here we have the requirements for the things that our package or software will be needing. This is
Manuel?
Yes.
Oh, just a question. Okay, so just before you kind of move on, so I've used the requirements.txt files before with the
Requirements
pip
TXT. Yeah,
freeze.
exactly.
Yeah.
On any if you are working, for example, here now I'm working in my virtual environment for CoronaWhy. Okay.
Yeah.
If I make pip freeze,
Uh-huh.
it will show me all the packages and versions that I have installed. I don't know what is. I think it's Zoom that is eating away my memory. But well, it will bring me all the packages that it has installed.
Mm-hmm.
Okay. So I can do something like pip freeze to requirements txt, but
Okay.
this should not be here on the TLR file. This should be on the outer directory. So now I have it on the main. I have here the requirements txt, okay? Because
Okay.
this,
Okay.
what you want to have to bring the people who come to your project, okay, is that when you have the first page of the repository, tells me everything I need to know about the project, not the software itself, about what code is there. But for example, the README, I added these parts. You can we can start checking from my files, and maybe it's faster than from the notebook. For example, this is the Git Ignore. That is the file that you tell which files you know you don't want to track. Okay, because are, for example, the data files that we don't want to have in the repository, Python objects,
Mm-hmm.
downloads, X, and things like this. Okay, so for example, this Git Ignore helps you to make this. Here, I add the embeddings file and the zip for the embeddings that I downloaded from Google Drive. So this way is not making dirty your Git space.
Okay.
Okay.
So my question was, is the requirements.txt file or the config file that you were referring to a minute ago? Is there a
I
preference to
mean,
do one over?
I mean, this depends on what scope you are working.
Okay.
Okay. Because one thing is doing an application and one thing is doing a library. I think one thing is like I'm giving you that is the end tool that you have to use, okay, and or you have to deploy. And another thing
Mm-hmm.
is I'm giving you like, it's, for example, if you tell me I don't know, this same package that we are doing, okay, is should be working the face document search, that okay, I can search. If I got my Mongo configured, I can search for similar articles. Yeah,
Mm-hmm.
but for example, pandas in itself that we use, it is not a tool for itself. I mean, it's a tool for building tools.
Mm.
That is a library. So when you are doing an application that you want to, that, for example, you are the one controlling where it's deployed, you want to have the requirements that you have on production to make able to replicate the same exact environment everywhere. That's why all the virtualization tools like Docker and Kubernetes and backgrounds exist, because what you want to be able is always to say, I'm the typical problem for developers that, oh, it works on my local. I want to make sure that what I run on production, what I run on testing, what I run on my local, what I run on a Mac, what I run on a Linux, what I run wherever is the same, or as close as the same as I can.
Mm-hmm.
So this is why you will use requirements with an application that you control. But when you are doing one tool that people can use with different configurations, like pandas will say, I need NumPy, but I can accept all the NumPy versions from range from 1.4 to 1.20. And then you offer a range and you put them on the setup file, because you want them to install as a package.
I think would it be correct to say that the differentiation, or a differentiation you could make between a requirements.txt and a setup.py is that the requirements.txt file is really for the person who is building all of these packages for the developer in production, while the setup.py is more tailored for how the end user is going to
Exactly. I mean, the thing is that you can always make a library that it works as an application. Okay, but you can make a library that is not at all an application. Usually, what I finish doing on all the projects is setting up a setup.py. So you can install as a norm or as a regular Python package, and it resolves its dependencies using pip automatically. You can run post-installation scripts, configuring everything you can need and doing everything nice. But right now we are doing like the first iteration on a windmill that needs to start working. Okay, so the thing is that, for example, what just summarizing here on the requirements, this is something that on the notebook it works, but we will try to never make installs like this on the Python models that we do, because this outside of a notebook, it will not work.
Right.
And it's not the correct way to do. The correct way to install dependencies is at installation time. When before you run the code, you say, okay, I'm going to prepare my environment. Okay, this is another part. Here we have this one run unless you are on a collab. I changed that. We will see it later. But that. Sorry, because I lost. Yeah, okay. So here what we were doing is that we downloaded the embeddings file. Here we load it as a data frame, and we connect to the Mongo. And then is when we load the files search, and we prepare the vectors and the embeddings. And after we, where's here now? Shit, this is hard. Okay, yeah, this is the documenting the similarity search. We have prepared the vectors, and then is when we do the searching that I done here. This is the preparation of the query that in fact is that important step that you mentioned that I forgot to do something, but I checked and I wasn't able to find it. The thing is that here of all this process, okay, all this code in terms of the process. I mean, one thing is this code was required from the task. I think it was TIES or VT to prepare the notebooks for the presentation. I'm sure that they don't put clutter in here. But what we want to do is to separate the part that actually do the index search to the part that is configuration for your environment, that the part that do orchestration and preparation. And this is more or less the approach that I take. And now we are, I'm going to start. So the thing is on the Steam literature, this is my refactor. Yeah. okay, this is the, oh, look, I didn't put them, but I mentioned that we're required to install. Okay, the first thing is that if we see on the original repository, we don't have almost any explanation of what is this for, what do we do. So somebody arrives here and I tell you that the front page of the repository is what the first thing that we're going to show. So at least we need to explain them what do we do and what do we need to prepare their system to run our code, and a little example that should be working. Yeah, so here what I make is all the changes that all the code that you have there is underneath this function. You only pass the UIDs for the articles that you want, or the titles, and the number of results that you want to obtain, and that's all that it needs. If we see here, if we come to the original notebook, uh, all these things can be moved to Python files, and what you execute, you only run the part that is required. This is defining a clear API that on a high level, it takes only what is required, and under the hood is doing all the process and the orchestration. Now we see, let me show how we do, and we discuss where are the pull requests. So more or less, the first thing that we have is this is a notebook. Yeah, okay. This is taken from in comparison with ways. Yeah, in conversation with here. No, with this one. No, with the this zoom menu is. Oh, sorry. Okay. Factor master. Oh, yeah, the Python file. The first thing that we have on the Python file, okay, is this. I don't know until which uh, how much you are aware. So I explain everything from the scratch. If you feel that I forgot something, please ask. Feel free to ask. Okay. When you have a Python file, you have two ways of accessing this Python file on the Python interpreter. You can import that file, as we're importing here pandas, or you can execute that file, like saying Python name of the file .py. Okay, so at import time, we are not intending to run any code from the library yet. I mean, we are bringing these definitions to our namespace so we can use them, but we don't want to run anything. Yes?
Yes.
Okay. But at execution time, you want to execute. But the thing is that the Python interpreter will come and will do exactly the same thing in both cases to the files. It's just that the operative will be different. And what it will be doing is taking the file and reading it line by line. Everything that is on a top level, that means zero indentation, okay, it will be executed without fault. All the imports, you need them, so it's good to have them at top level. If you have a problem, different versioning and stuff like that, that is more complex that we are doing now, maybe you need to put them with if conditions and things like that, but usually you just put them. But for example, all the things that you are doing here, this will be execute no matter what. Either you import them or you execute them, okay? But the functions won't. I mean, if I define this function that is defined here, won't be executed until it's called. But for example, here, we are trying to set up a client with the CoronaWhy Mongo. Okay, let's ignore for a moment the fact that we have these credentials here, because I will discuss this soon not in the terms of security, because we were assured that these credentials can be shared because are on read only and should have no privilege nor similar stuff. But the thing is that what we are doing here, that means that this line, this client equals Mongo, that means that at the moment that I'm trying to import this, no matter what the circumstances, I'm trying to connect to Mongo. And if this Mongo is not available, it will crash. That means that if I make import phase document similarity search, I will receive a Mongo error. This is unexpected. When we code, when we do software, when we do any kind of intellectual work, they say that there is this law of minimum astonishment, that some things are good when there are no surprises, but everything is as it should be. And this, for example, is something that should not be. No, there should be no calls directly on the lens. You can make definitions. This is not good because you are using credentials, and this should be a separate file. But itself, the definition of things like the embedding file name is not bad. The thing is bad is the execution of code. I mean, here I define, for example, here I'm loading the config parser, and I'm loading the configuration file. Here I'm defining the base directory. I'm setting where are the credentials for Kaggle. I'm setting the name of the dataset for Kaggle, the embeddings file, and the folder. But I'm not executing anything that can fail, because the config parser, for example, the setup, the file that is looking for is not something that the user will give me. It's something that I put there myself, so I can be absolutely sure. In any of the other files will just say, okay, give me this path. If this path maybe is false when I checked, but not when I defined, this will be just a string with some value. Later I can say, oh, there are no credentials for Kaggle, and I say, yeah, but this will be when I execute it, not when I define it. So for this part, we are fine. And we see that all the things that we have are defined inside functions. That means that when I import this file, the only things that are defined are these names, the configuration, these constants that I put them in uppercase, so everybody that access my model knows that these are constants, and the function that I define explicitly. No more execution. You see how this is different, I think. Yeah.
Yes, yes.
Cool. This is important because when you want to be able to execute, I mean, the thing with software is that the machine will do whatever you tell him, and the machine will do things that if you are not aware, I mean, the machine will do what you tell them, but sometimes you are not aware what you are telling the machine to do. So you need to be sure that you are in control, and being in control means that you know what should be happening at every moment. I repeat the thing of the least astonishment. This is not on Python programming. This is general engineering good practice. You should have an idea of how things go. Then here we have that we have some definitions, and then we have the final execution code here. Okay. This in itself is a bad practice, because when you want to execute things on a Python code, on a Python file that you can be able to execute it, what you do is something like, let me just use something that I made it before. I think it was here. Yeah, no, not here. Yeah. If I put this, if name main, okay, name is a keyword in Python, okay, that the importer sets when loads a file. Usually, the name of a file, the name of on one file is the name with which one with. Sorry, now it is the name that is used to import that file. So if I do import pandas, double under name double under will be pandas, okay? But if I do, if I have this file and I execute it and I make Python name of my file, then the name will be main. So this is the thing that lets me know when the code is being executed and not imported.
Right.
You follow me?
Yeah,
Yeah,
this is the difference between a script and a module, right? So
exactly. But you can have something like one module that have definitions of functions, and it have one main. So you can call the module, and it will call the main, and you can have
okay.
because you can have for the same code multiple interfaces. Interfaces means in which ways I'm accessing the functionality of the code, in which ways I can make it run. I can make it run like on a standalone, like I have this. If I have nothing on the here. This should be doing nothing because I hope now because there is no main. It's defining the stuff, but there is something that is missing. Oh,
Yeah, no, it's the Kaggle. The Kaggle was driving me crazy. But
yeah, maybe I need to recheck because this was unexpected. But the thing is that if you want to have your code that want to be execute should be under if name main clause. This is the scripting part of your code. Okay,
yes, yeah.
cool. Then next thing, I put this on the settings that I want to know if there is no settings Kaggle credentials. It should be here. For credentials, config Kaggle credentials and config parser. There is no Kaggle. I will check it. I will check it because maybe I wrapped it around and I was switching between projects and maybe I forgot it. Okay, here for yeah. Sorry for this
That's
was. Yeah, here we have load the config, and here we have the loading of the credentials from Kaggle. What we do is if we have this path, because the credentials in Kaggle, in fact, they give you the file, the file that we're looking for, but you can have them also as environment variables, okay? And when you are deploying it to a server, okay, on the server, you don't want to store any personal information in a file that can be accessed or that can be that should I mean that will come in a repository so somebody can take
yeah.
it from some other place. You want to set it manually as environment variable. This way is only unless you hack into the machine, you don't know this secret. Okay, so this is why we load them and we put them as environment variables because Kaggle automatically will handle the environment variable. So if you tell me load them from file, I just put them on the environment and that's all. When we do these load credentials, you see that I pass it anything. Kaggle handles it for me. Okay, the only thing that we'll do here is returns an API object from Kaggle that will allow me to work because all the stuff that I was not able to download it from Google Drive and I just automatically generate it from scratch. This is something that connects to a random connection in Mongo. This is separate from the data. This is it knows nothing about CoronaWhy. It knows nothing about Cord 19. It knows nothing about. It just knows about Mongo host user password database collection. And with this one is the one that we call with our credentials for CoronaWhy that we will get our server. Yeah, this is to make it reusable. So you can say, I can use CoronaWhy's Mongo, or I have my own because I'm super good at natural language processing. I generate my embeddings and I want to use them now. So you have both options this way. Yeah.
Yeah. Yeah.
Okay. This is to clarify because sometimes even if the function is 2 lines, I prefer to just have something that explains what it does. And in terms of code, it later is uh, easier. I mean, for example, here when I say get code 19, you don't know where you get them. Here you know that it's from CoronaWhy, but in fact you don't care. What you want is something that you can query and query like a Mongo object. So it's good for you. And here is, well, what it gets the UIDs that now with the indentation of GitHub is a little. And here, no, where it was that didn't Margan. Sorry, I can see your names now. How many people is here? Ah, is Anton here also? Okay, Matan, sorry.
Everyone.
Hi Anton. Um, you put a comment that now I don't find, but I thought that it should be here at some point on my. You make a comment of about.
It was I put a comment about the phase. What was it? The order of. I don't think now.
Okay, but there is okay. But this come from Facebook. Okay. So we need to add something that we didn't have on the original version. Matan?
So yes, go ahead.
What you are telling me is not that I misplace one statement when moving from the Alex or Tastai's notebook to what I put on the pull request, but the guys that make the library has changed the specification or something that we didn't do well on the first time.
Correct.
Because I check step by step and I say I could swear that it was the same line, so that's why.
Yes.
Okay,
Yeah.
I will add it. There is no problem with
Oh, well,
that.
I mean, I put that comment there so that we could have a discussion about it. Just from, I was looking at, the phase, the original library documentation. It seemed to me something was out of order in our work, but just
No, but I will check it and change it.
okay.
No problem. Well, the fact is the part that is used that use the phase search is here. This is we have it separated in two parts that was preparing the vectors and everything, but in fact we don't because in a what is this? Yeah, first no, this is my example and this is the old one. Yeah, here we need the query vectors that we are preparing here, that we load the embeddings and then we do some preparation of the vectors here, that these are the things that we will pass. This line 68, we generate the XB, and from the XB we generate the D, and this is what we pass to phase, and from here we start doing the query, and then with the query we search. So I put it all together because it doesn't make sense to say, well, I'm gonna generate the query, but I'm not gonna use it yet. I'm gonna be passing it around. I think that it makes more sense to say you give me the embeddings, you give me what UIDs you want, and the number of results. The next thing you know is that I am returning you the UIDs for the similar records, which is the search itself. So everything that is using phase is encapsulated here. There is no more. I mean, we can change this function with something that doesn't use phase, and we can delete completely the requirement because it's all encapsulated here. This is usually a good practice. I mean, so if you need to use some library at different places, feel free to do it. There's no problem with that. But if you have, for example, one specific process, like for example, here we have also with the Mongo. Okay, let's say, okay, Mongo, I want to have just one point of access to Mongo. Let's say there is only one piece of code that handles the connection to Mongo. This is what is called the single responsibility principle, that it means you only need to do one thing. I want my code to do just one thing. I don't want to bring me the newspaper and cook pancakes, either pancakes or newspaper. But both things will give me trouble in the end, because sometimes I will need to sacrifice one of the two things to do the other. And so it's no, I just do something that connects to Mongo. Only Mongo. It doesn't care where is the Mongo, where come the credentials from. It doesn't care. He goes, connects to the server, gets the database, and returns a collection. Here we do more or less the same. I'm not so sure about these steps. I'm taking Matan criticism that is something that is failing, and we will check it. But for example, I'm not familiar with this library. But I know that if it's intended only for the search, it makes no sense to being using it in 3 parts, because that doesn't mean that it's really required. That means only that we are splitting the functionality in 3 parts. And if there is no strong reason to do something in code, usually the less the better.
The only thing, quick comment about pulling in embeddings there is that the Kaggle kept on failing. Plus, we don't know if
Sorry?
so. So the other issue that I had with that function was that pulling in embeddings there, the way it's done, number one, Kaggle API kept on failing, and number two, we don't know if every single time we want to run this that we want to download fresh data set from Kaggle. So that's something
Yes,
else
and
that
yes, what you are saying is reasonable, but I think that I can answer to that. The first thing is that um, for a data set is always more reliable if you download it from the original source, even if you can have more downtime, because you are is one way of saying, hey, I'm taking the original one, because I can take one data set, I can curate it, I can call it the same name, download it from my server and say, oh, I check it with this data set and it works. In terms of reproducibility, is good. I know that we have problems with the Kaggle API. Okay, but this is something that it comes inherently from the fact that we are connecting to the original source. About the downloading, how this works is that this download embeddings, he looks for the path. I mean, you bring it. I mean, this is the actual downloading. Okay, that this is the handling of the downloading that generates a Kaggle client, gets the file, downloads, extracts, remove the artifacts, and returns you simply here. No, here is only the remove and uncompression, and then you do the reading here. So what you can have is, I have embeddings that somebody give me and say, okay, if this is a valid embeddings, I return the same. This way you can pass, I have generated or obtained it somewhere else. I don't care. You are already on the end format that I need. I let you be an argument. I just return it unchanged. If you give me one path, if this path is not a file, what I consider is that you are giving me the path where you want me to download the embeddings, and I download it one time, only one, and then I load them. I create a data frame loading the contents. But if you see, for example, here, I'm generating all the time the same embeddings. The get embeddings is called all the time with the same structure. So if you are not moving the code around, you are not doing crazy stuff that you should not be doing if you want to be able to replicate results, you only will download the embeddings once, which is something that you will have to do because it's required. Just like you tell me, we are letting you the Mongo, but you can do it also with Elasticsearch. But you need the Core 19 data set somewhere and in a format that you can query in order to be able to retrieve the documents.
Yeah.
So it's something that is heavy to get installed. Yeah, but we are simply doing a project that works with heavy requirements. Simply as that. And then it's 4 GB. Yeah, I know. What we cannot do more than that. Yeah. And then the thing is that we have this function that downloads embeddings. This orchestrates the getting the embeddings, making the download if it's necessary. And this is the actual face call to do the search that only returns the UIDs. And here what we have is to put everything together. We have arguments that can be titles or UIDs. If both are missing, then I tell you that they are missing. You can give me the embeddings, but I don't require them. If you bring them, I will use your embeddings. If you don't bring them, I will download or use the ones that I have already downloaded.
Okay.
Once I got this get UIDs, what it does is that I'm assuming that I can have titles and I can have UIDs. If you use just one of both, this is just a corner case. If I assume that I have all the time on the worst case scenario, then the other things are happy endings. So here what I do is simply, if there are not, I explode. If there are titles, I query them on the database. If they are directly UIDs, I extend to my list. That is the result that I make. So you give me titles or you give me UIDs, I end having UIDs. And with this, I do the search, I get the collection, and I return a data frame with the articles finding on the collection. I haven't been able to check the collection to Mongo, Okay, this is something. I mean, I put it because I wanted to discuss with Alex. So because I know that you are working, and I want you to start getting some of the ideas and being familiar with the abstractions in the terms of software development and good practices, which are sometimes different that data science good practices. But this is why I was telling about offering multiple interfaces. That means that for every one of these kind of scopes of way of looking at the project that we are doing, we need to be able to offer people what they are looking for. So this was the main phase that you see that were for. It's good to have doc strings explaining your API if the formats can be weird or something like that. I didn't make them. I will update with them. But it's also important to have something that, like here, you can use to say, okay, what is here? What is happening? How can I use it? Okay, look, I think that this failed on my local because I couldn't connect to Mongo. But for example, this is more easy to follow, that you say, oh, you give me the UIDs or you give me the titles, you tell me how many results, and you just have the results.
Yeah.
It's easy as that. Underneath, we know there is a complexity, but to the user, to the end user, that we must assume that sometimes the user will be not of a high technical level, that only wants to find articles. He don't want to know how to connect to a Mongo database. So we just offer it him like this. And on the last part is, there is here, this is a setup config. This is a standard for Python. When you have configuration parameters, like for example, access to something that is, okay, I'm putting you mine, in this case, because CoronaWhy is is acting as a good faith actor, okay, and is letting its is letting access to its Mongo. But you can not expect that, for example, Google will let you will pack free API keys with their clients. Like, oh, you are using Google Cloud Computing. Check using this API key. No, they tell you you need to register and you need to put it here. So the way to make it to have a separate place from the code to be the data is the setup config. Here you need to put all this stuff that is external resources, credentials, and stuff like this. To Because this way I know that if I want, I can run everything and just change from where I. Well, this is to download the dataset. In fact, after I download, I don't care. But I can change the Mongo without looking at a single line of code, only changing the credentials from here. So this is something that we want to offer to the users that of our library. There's any doubt about any of the things that I've said or have explained?
Uh, I'm good so far.
Yeah, I think a
Okay.
lot of this makes sense. One question: how are you loading the setup config file? Like
Well,
that
the
again?
thing is that I explained, I put it here, like vector embeddings is, in order to perform the similarity search, we need the documents into embedding. We use the embeddings, and I put the link. Okay, you can open it. It says Kaggle, directly the file of the embeddings.
Yeah,
So I'm putting it easy. And also I'm explaining that you need to have your Kaggle credentials, and I put you to the documentation of Kaggle that explains how to handle the credentials and how to do how it works by the
Mhm.
original source. So I think that anybody that is more or less familiar with this kind of stuff should be able to put it without
Right.
Alex,
be spoon fed.
I think the Kaggle API looks for that config file.
Yeah,
Yeah,
you
no,
can you can go to your profile and you download it and you just put on this location.
I guess what I was saying is like where in the document similarity search py file,
Yeah.
like is it called in there?
I think that, yeah, no, okay, because I make one little. There's something that I will need to check because you about the requirements, because I make a little trick, because on the first
Oh, the
this
config
I
dot
use the
parser.
Kaggle. Excuse
They're
me.
line 15 and 16, lines 15 and
How
16.
do I
That's
load this? Yeah, okay. This
yes,
is
okay. I see it now.
What I do is this. Now in config, I have like, let's say like a nested dictionary object. So I can access, like, for example, here, config Kaggle, and this will be a Kaggle credential, sorry. You see that it's double bracket, double key access.
Yeah, yeah. Okay, got
Or
it.
here that I have Mongo password, Mongo database, Mongo everything.
Yeah.
Okay.
Okay,
So
that makes sense. That answers my question.
cool. So this is more or less, if there is, I mean, there are a few things more that I would like to change, but I wanted to make clear this. First of all, is separation between what is data in terms of the. I mean, it's like if I'm doing a barbecue, I need to be able to differentiate what is the grill in terms of is something that will stay and I have always with me. What is something that is like the meat, that is something that I use with the grill and then is the thing that I consume. Something that is like the plates that you say, okay, it comes with the meat, but I don't eat. You know, there are different things. So we need to differentiate, for example, what is the data, in this case, the embeddings and the Mongo that we are using to perform this process, and the Kaggle credentials from the embeddings will come in this part. We have to differentiate that from the user input, that is the actual UIDs that they are telling us, the code that prepares everything, and the code that it does actually the stuff. For example, in the here, all the Mongo installation, all the how was I say? Yeah, all the Mongo, all the credentials are splitted. This, all the access to Kaggle is 1 point. All the access to Mongo is 1 point. Here, I'm using another access to Mongo, but it's based on the first one. So everything, every external resource only is accessed through a 1 point. So I have control that is, as I mentioned before, if you don't know what is happening, then you are not coding well. Even if you get results that make sense. Okay, so for example, when we do here on the final function, you see that, for example, this is our orchestration. This is preparing resources. This is also preparing resources. And the actual search is just these 4 lines. Yeah, but because everything is a split, so when I know that if I just want to get the UIDs, I just can do the face search, and then maybe a query on Mongo, maybe a store, then maybe do whatever. But it's a functionality that on itself it makes sense. If I come looking at the notebook without making blood, but for example here, when you are doing setup phase for for document similarity, okay, you run this, but this on the only object that returns the index and the query you are passing directly because you require here. So why don't you have the document similarity search made itself the setup? For example, so we try to make that the abstractions that we use on the code and the names that we use on the code make sense, the objects and the functions, in terms of the abstractions and the processes that are happening underneath. I could put them, all this code that here is, okay, all this code that is here, I could put them in a notebook without any functions, without any indentation, and make it run as a single script, like line by line. You know what I mean? I mean, I run this here, then I prepare the Mongo, then I could do everything without functions. But if I make this and I put it in an order that it runs, I can split it in functions with any separation, even if it doesn't make sense as abstraction. You know, it's like, okay, I have 100 lines of code. Where I split them? Line 81. Say, what are you doing there? I don't care. And you know the part. So it's important when we organize the code to make something that makes sense for itself. So sometimes it's like, can we make this? Can we reuse this later, or it makes sense in another context, or stuff like, or how it's gonna be used in the end, or what possibilities offer. So it's important to take this in consideration. Like, for example, this here, you need the index and the query vector. So this line will be called always, so you can put it yourself. Or the here, for example, we have one thing that is that the embeddings file name that you have here, where it was, yeah, this was done all, this was based on your local, a couple more of little details, okay? First of all, is it was prepared for your local machine. It wouldn't work on any other. So this is what we need to be able. That is one of the things that we will make is a build. That means that we make run, test, and execute part of our codes and our demos by GitHub every time we make a commit. Because this time we are this way we know that it's not work. It's not only that it works on our machine; it works everywhere because we are doing things that are reproducible, replicable. That means that everybody can do and obtain the same results.
How is GitHub going to test for that?
Usually on GitHub, you can set up actions. I think that I have, yeah, for
Okay.
example, that will run the continuous integration system that you pass them. Okay. For example, here, what you do, I'll show you is easy. You can create a folder called .github. This is where you put the things for GitHub, and you can create a workflow. In this case, for example, the workflow says that every time that somebody makes a push on master or comes with a pull request to master, it will be execute. Says what you put a matrix of operating systems. This matrix is the combination of Ubuntu, Mac, and Windows with Pythons 3, 6, 7, and 8. Yep. So for every one of these combinations, we'll do the following. That is, set up the Python, set up the environment, upgrade pip, install the development version of the project, run a linting. Here we are using make, running the test, and differently on each one of them, but they will do the documentation just to make sure that we're able to.
And this is something that you created, correct? Not like a standard template that you can get from GitHub.
Yes and yes. I mean, this is something that I create for the TaskGeo team. But as you can see, I copied directly because I even left here the link because not hiding and not ashamed that most of this stuff. I mean, I've worked a lot with continuous integration. I'm familiar with the concepts, but there are a lot of libraries, a lot of systems, and I don't know them all. For them touch, I have to work with lots of them. I mean, maybe Circle CI and Travis that are the ones I'm more familiar with. I can read the YAML and check for errors, but I cannot write from a, I cannot, and I hope that nobody does write from scratch a file like this when you can get a template, delete what you don't need, and customize to your needs. This is exactly the one that we make. But here, for example, I start changing things. Here we don't put these parts because we have on the when I make lint, what I run is running the Flake 8, but I have one setup config on the project that, as I tell you, is standard practice, and I put them which parameters and which things for Flake and for iSort. So I don't need to, when I put Flake 8, it runs always with these parameters. No, the max line name is 99 and knows to exclude these folders.
So is
this
this sorry, is this I mean, this is similar to what Travis does, or are they similar but different?
There are here we have 3 different things, okay, that happen at the same time, but are different things. I mean, right now, for example, I'm drinking a coffee, doing this call with you and wearing shoes. Okay, but any of the 3 things has anything to do with the others. I could take my shoes off or start drinking coffee without interrupting the call. So here what we have is, first of all, is the continuous integration. When you say continuous integration, you mean that you have one server, usually is connected to your repository, that there are actions on the repository like pushing code, like adding new code that will trigger actions on this server. Usually these actions are a script and implies running the test, but can do different things. You can run the test, you can check the documentation, you can build different kinds of artifacts. I can have in another project that is private, I cannot show you, but for example, we build Docker images when we push to the stable branch. So we have one Docker image for release. Yeah, but we don't run tests on that, because the continuous integration simply means that from the repository, I create actions. Usually this action is what we call the build. That means run all the tests, check everything is on place, all the code quality and quality assurance procedures that I have set up in place. I want to run them because this is more security, that my code is working as is intended and I'm following good practices. But this is the build. The build is separate from the continuous integration. Then the second part that we have, that is, let's go back to the file. Here what is running on GitHub is the continuous integration part. The continuous integration part inside itself, what it does is this installation and run, make test, and make lint. Okay? Which are in fact the build, but the build is done at a repository level. I mean, the build is something that I have on this make file. Are you familiar with make?
No.
Okay, make is a command line utility tool that it started being developed to handle all the complexities of compiling C code on large projects. Like I need to create first the libraries, then linking, then compiling another part, and then so sometimes it's complicated. So make has this language that you can define objects, you can define things and run commands. But as it's quite flexible, has been adopted not only for doing the compilation of C code, but later on also to handle all the standard procedures that you can have for a repository. In this case, for example, you can handle the installation because it's a Python package, running the test, that is the thing that we see on the continuous integration, linting. We can generate the documentation. We can clean the artifacts that we generate. We can, here is to make the distribution, the BDS wheel. The thing is that everything that you usually need to do on your project, you can put it on the make file instead of put all the commands manually. You know, it's like mini scripts, like bash mini scripts to handle your repository. There are a lot of make files that are included and that are free to share using standard good practices for almost all the languages of all the code languages that at least I work with. So it's quite similar. This is the make. This is something that is done at repository level. Yeah, and then we have at repository, but I could have one repository that is not a package. But when I have one package, this is where I have the setup config that serves as configuration of this package. So here, that's what I was saying, that when you are seeing GitHub doing that, you are seeing three things, one over the other, but they are aligned, because we made it that way, but they could be very different. They could be other stuff. Does this answer your question, or maybe I?
No, you just gave me some more things to think about and to read.
Okay, so let me.
It's okay.
What was the question again? Can you repeat it?
I was trying to understand the difference between using Travis and GitHub Actions for continuous integration.
There are when I explain you what simply is, there are two different services. Like what is the difference between programming in using Django or using Flask? You are doing Python, but you are doing different flavors of Python. Both offer continuous integration, but each one in its format.
Okay.
That makes sense.
Okay.
So Manuel, what I'm getting from what you're teaching us is when like as we're working with this stuff, we want to one create like a requirements.txt file or a setup.config. Two, we want to make sure that any secrets are going to be or setup data, I guess, is going to be put into that file. And three, we want to break up each of
No, let me
individual action in
put
the
it.
functions.
Let me put it. Let me tell them myself what are the points that I think that you need
Okay,
to. Okay, the first one
great.
is that you have to make code that works with the least amount possible of astonishment. That means that it does only what you are telling him to do. For example, that was the example here about not executing code at the module, at the file level. Here, all this will connect to Mongo. If the Mongo of CoronaWhy is down, you just simply import it, and before you have finished defining functions, it's already crashed.
Okay.
So
Okay.
the first thing is least astonishment possible. That means that you need to do the things what you are told so, but you refrain to do anything unless you are being told and is necessary. In these terms, is you have to do all that you are required to do, but the less you do after doing all is required, the best. In terms of this, of doing, I'm not doing things without telling the user, I'm not doing weird things that are not required, etc. This is the first thing. Well, are you familiar with the Zen of Python?
Yes. Yeah.
You know that you can make the import these. Sorry, my computer is, yeah, here. Beautiful is better than ugly. Explicit is better than simply. Simple is better than complex. And these 6 lines, well, and readability counts also. The thing is that we must understand the first part is this. We need to make that the code only does what it does and explains what it requires. It does. If you can make the user doesn't get a crash because he read the documentation, the good users are the ones that read the documentation. So we need to put the documentation and everything. So the people who try to do things well get to find results. Somebody don't do and get problems is another story. Then second principle is we try to make things, the code and the names and how everything is orchestrated. We try to make that the Python objects and functions are as close and as similar to the abstractions and the processes that happen and they are doing. I mean, it will not, it will make no sense. For example, like I always say, for example, sorry to return to this example, but this was clear, to have this function that is required to another function and it has no value to itself because it only generates the query vector and the index. So here, this should be included. So we try to make things as close to. So I'm doing the search, and I just everything that I need to do the search as are the arguments of the function, and what I return is the result of the search. I'm connecting to Mongo. What I need is the only things that I need to connect to Mongo, and what I return is the object I retrieve from Mongo. I'm trying to prepare this data for the processes, where it was the get UIDs or that. Okay, I'm just taking one thing, doing one thing, and make it clear. Having these functions, like I work like this. I mean, I know what I mean is like, I don't know if I have something open in any project. Never open a Jupyter Lab like this. This is takeaway maybe on the 9. I got something more data scientist. Yeah, but this is not. The thing is that I work with notebooks and my notebooks are dirty, and I wanted to show you, but this is confidential project. Sorry. Where I have, well, I don't have a Jupyter with that now, but the thing is that all the code when I run in notebooks helps you and lets you get away with using a lot of bad practices. Okay, so it's important to make this separation. And I say the point two, that there should be as strong as clear correspondence between the functions and the objects and the process and the abstractions that we use. That's
You're
it. That
you're building many small building blocks.
exactly. And
It's
each building
Legos.
block, it does only one thing, and
Right.
and only takes the thing that it needs. Like for example, what I was saying, the connect to Mongo. Connect to Mongo. This is the most minimal thing. If I could delete one line and be sure that it work, in fact, I could change the URI and put it inside the definition of the calling of Mongo client, but I wanted to make clear. Okay, but the idea is that I do only one thing and I do it well.
So build small building blocks without having to do any extra work.
Exactly. You do a small parts, you build big parts using the small parts, and you use these bigger parts to build even bigger parts. And this is how you uh, start building. If you make one gigantic function of 100 lines,
Yeah.
probably it can be split into smaller functions that make sense for themselves.
The Jupyter is nice because it helps you see what works and what doesn't quickly. But then once you're finished with that, you break it down into the small building blocks.
Exactly. Okay. Then
There is a
Mm-hmm.
let me just add a quick thing that actually helps in this regard. So there is so-called like dry principle, don't repeat yourself. And if
exactly.
you follow that principle, you will end up exactly what Manuel is describing. Like you should be in this point, and you will be at this point when you, let's say, start even with Python notebook that exactly gives you a lot of leeway how to run things. But the moment when you start actually kind of like, okay, here is the cell to connect to this MongoDB. Here is, but then, it crashes. You kind of like, oh, you know what, let me add another cell and I will connect to my local MongoDB. And you essentially copy pasting the same cell, you just, change password, credentials, etc. And at some point you will have multiple cells that are like copy and paste, and you'll be like, wait a second, I need a function to do exactly that. And this at that point, you will be kind of like, oh yeah, let me run define get collection Mongo function, and so on. So eventually, if you go through this process of, again, not following anything, but just simply applying dry principle at some point and refactoring your code, you will end up at a very similar endpoint that what Manuel is describing. But if you have already this kind of thing in place and you already know that, wait a second, it's exactly the issue. Mongo is not always, up and running. Kaggle is not always up and running, etc., etc. It is great to have already start from this one, like small fun. I mean, it just you kind of going ahead a couple of steps from just going it, go for all of the smaller steps of refactoring. Hence, like why, like experienced software developers, they will kind of immediately looks like they do a lot of boilerplate code that you kind of like, why all of that? But it all makes sense at the end because eventually everybody will be at the same point.
Exactly. The dry principle is, maybe I didn't mention, but is also important. Don't repeat yourself, and working is smart. It's like sometimes you have three functions that are basically the same, but for example, it only change one call to one function, another calls to another different one. So you can say, okay, then I need to create one function that this parameter that is the only difference. It comes as an argument. So I have the same function, I just call with different arguments. So this is when I say that where you put the indentation, where you put the scope, when you say, no, from all these lines of code that make no sense, I can split this part, and this part is only connecting to Mongo. This part is only cleaning the names or retrieving the data or whatever, but it's only that. So the second part will be this one, to make this correspondence between small steps and functions, building a small blocks, and especially that the abstractions. And when you say, for example, if you try to explain somebody who doesn't know how to code, what is the process? Okay, and you say, well, you have these embeddings, and you take the UID from the embedding, and then you process it doing something that is called the file search, and then you retrieve the UIDs from similar, and then you go to Mongo and you take the articles. I haven't put it in any kind of Python code. I just explained the process of you as doing with paperwork. Okay, and if it was like offices and these calls are like I'm sending messages by postal mail, this abstraction will be the same. I can translate directly, and there is no code. But these steps have the correspondence with the functions. This is what is when you are coding in good terms of abstractions. This is complicated to get, and sometimes me myself I rechange functions 3-4 times. This is normal, no problem. But we need to aim to do that. And then the third point, and this is the most difficult to articulate at any point for any software developer, but it's something that we need to take care. And it's the fact that we have one functionality, but there will be multiple both interfaces and use cases. What I mean is that we have this document search, okay? Then this document search, I can use it like, yeah, I'm Manuel and I'm checking that my code works. So I try to run a document search with some dummy documents that I put. I'm using the default embeddings. I'm using the default CoronaWhy. I don't care about the internals at all. I can use it like, let's say, oh yeah, I know what this does, but I want to use my embeddings and I want to use my Mongo. Or I want to develop something that integrates with this, so I need to put the call, and there are infinite ways of using this code. This function, document similarity search, just how you want to expose it to the world. Like, what do you want to do? You want to put it like an endpoint for a web service? You want to put it in a library as a Python package? You want to put it in a Docker image? You want to be called by RPC? I mean, there are infinite ways to do that. So you don't have to choose one, but you need to make your code compatible with as much as these different ways of being utilized, being used with that. It's like, if, for example, if I added a check that the credentials should be the ones from CoronaWhy, then I'm putting sticks on the wheels for somebody who want to use their own Mongo because they have their own infrastructure. So I say that's why I put it on credentials. I separate it so it's not on the same part, and and as long as it offers me the same interface, as long as there are valid Mongo credentials, I don't care. So this part, like for example, here in TaskGeo, okay, this is a little beyond and beyond. But if, for example, you look at all the things that we have that makes that the setup py, that makes that you can install it as a Python package. So a Python developer can install as pip install TaskGeo. It's already available on PyPy. The Docker file allows me to generate Docker images and either build them myself or generate the image and put it on a Docker repository. So you can make Docker install CoronaWhy/TaskGeo. I don't know if this is working. Now I'm talking by head. The fact that I have for example, this is compatible with different ways. If I have as a Docker, I can put it in a Kubernetes. If I'm having one build with docs, okay, I have here we were talking about the continuous integration. It's running with GitHub, but in fact, it's running with docs, because what GitHub does is doing the same that I have here on docs. So if I need to move from GitHub to Travis, I don't care, because you can access multiple ways. It's like for example, McDonald's. You can go McDonald's to the restaurant. You can go McDonald's to the drive-by. You can go McDonald's and order with the app, and then you go to the restaurant. You can order with the app, and they bring you at home. There are multiple ways to access, but are the same hamburgers. Here, our code is the hamburgers, and the interfaces and how we articulate these code files and what we configure is the different interfaces, and we need to make sure that it's accessible to all the different possible use case that we can imagine. Well, all we can imagine not, but at least that we can assume that are possible. Does this make sense?
Yeah, we're building a Swiss
with
army
these
knife.
three things.
Yeah.
With these three things, these are at least the things that I try to think. I mean, when I get something like now is more like personal reflection, but when I get something like, for example, the original notebook from Alex that I first go to check Christine once, which was also usually that it was, well, it's a long notebook that has a lot of processes and most of the things you are not familiar. Well, the first thing that you need to know is what is doing this, what this needs to run, what should I expect on more or less every step. If you don't, if you don't understand this, then you don't know what the code does. When after you have this and the more clearer image you have about this, about each component, what is expecting, what should return, why should it crash in this case, should I accept this kind of format or this other format. When you are starting to see and understand all these things, articulating these three principles, being simple and clear, of make a good translation between ideas and code, and to be able to let it be used in multiple ways is easier. But you need to understand what you are doing. This is the most important thing.
Got it.
It's good. Thank you.
Okay, and well, that, I mean, for the things that we discussed about, just to make it, um, Matan, you tell me about the well, the commentary that is here. I will check it. Okay.
Yeah. I mean, yeah, obviously, don't spend too much time on it. It's just, I think it was I think whoever originally wrote it, the normalization came a step too late. If my memory is correct right now, but I put a link to the phase documentation. So
Yeah, I will check it, and if there are changes that need to be done, I will do them. And I lost track of what I want to say. Yeah, Anton, are you there? Yeah. And there is this thing
Yeah,
that
I'm
I'm
here.
not able to connect to the CoronaWhy Mongo, and I think that I got the right credentials are the ones that Alex have before, but I haven't been able to connect.
Yeah, I need to check. Like we had some recent migration because we were having a Mongo cluster on GCP, but we ran out of credits. I mean, the credits that were donated to us suddenly expired. So when like we moved something to AWS, and I need to check that the Mongo cluster is up and running.
Okay.
Maybe there's some. So probably MongoDB right now is just simply not up and running.
Okay, no,
And
just
could
because I wanted to make an end-to-end test using everything.
mm,
Because, for example, all the collection to Kaggle, I have run it and have checked on my local, but as I
yeah.
couldn't connect to Mongo,
Yeah,
I
this is
wasn't sure.
exactly the great example, like why what you were telling us today is extremely important is just because like the moment when your code relies on somebody else's, not even code, but service up and running, you start running into a lot of roadblocks that shouldn't be there to begin with. But yeah.
Yeah, but this is just for that. And then the other thing, just one final detail about, I was finishing before when I was summarizing the three principles of trying to make things simpler and expected. Like there are no surprises, and everything does what it should be doing. And the second one, that it was that there is correspondence between the code structure and
And
the ideas
abstractions.
and abstractions that we have, and the and the third one about offering multiple interfaces. For example, one of the things that I did and later I passed fast with this is I added these sections on the README, because I consider that it's important. There is these guys that I worked with, that, well, these guys are from the MIT, so are quite good at doing their stuff. But for example, when this is the README of one project that is called SDB, and you have, for example, the overview. I explain what I do. I explain you what are the features you want to try. You want, and well, they have, I want a Slack for offer support, how to install, what do you need, how, and a quick start about how to use it in the most simple way. But these offer some insight that now we don't have, and this should be good to have, like some reduction on that. And this is, and if we for each part of all the pipeline of the literature review that it was done, but some people that I think that none of them are us, and we need to take this code and make it, let's say, more standardized. Standardized in the terms that that was a prototype. It was a super cool prototype, but we need something that can be run like using the standard procedures and everything like that. And we need to understand these things. We need to be able to answer these questions fast. Like, what does this project take this? For example, when I take it, I have talked with Anton before looking at the code. I have talked with Alex, but everything, it was nothing when I get there and I start reading the code and I say, okay, let me go piece by piece because I'm not understanding nothing. One of the things that we should add, for example, is like the small examples that we are having here on the tutorial or something like that, how to use it. You can use me like this. You can that is like a little what I make on the quick start, but maybe better formatted. And that's, I think, all that I wanted to comment in terms of this. I didn't. Yeah. Sorry. That was. I think that in the end, I'm just circling around.
No, the last point is actually very important. It's great to have smaller examples of how to use it, not to import like the whole collection from Mongo, for example, of all of the embeddings, right? But on something small, etc., just for people to have the pieces to try first.
Yes, but
right.
Here there is one thing that we need to understand, that, for example, this as we are building something that you can use using different embeddings and different Mongo, because in fact, as long as the embeddings are generated from the original dataset, you don't need it to be the core dataset. As long as the structure is the same, I can take another natural language processing dataset, generate the embeddings, and repeat the process, and should be no problem. But the thing here is, for example, that on the use that we intend to do, and that's what I meant, that we need to make something that we can use for what we want, but allows other people to use on how they want. Here on our use, we will be needing both the Mongo and the embeddings. So it's like this is a big project, and the part of having these requirements and having to download this. I mean, we have here these examples. Even if we are doing 5 files, where is the here? Even if I'm looking for these 2 IDs and these 2 titles, I need the Mongo and I need the embeddings, and I need the 4 gigabytes of embeddings, because if not, it won't work. So it's a requirement. I was even thinking that if in a further iteration, we put something like a Python package that we can make on the post installation, check or download the embeddings, check that you have the Kaggle credentials, and download the embeddings. They say, okay, this is something that we are going to be needing. So we do it now. Because if not, you can find that you deploy this, and the first request that you have, it will need to download the embeddings and unzip them, and it will take 20 minutes to answer a request.
Mm-hmm.
But well, this is for another day. But I think that more or less this was all the things I'm gonna.
Manuel, do you use or I don't know if you have a preference. I was going to ask if you guys were okay with switching to GitHub projects instead of using the Trello board.
Yeah, about the Trello board, I wanted to mention that I saw that there are issues, and I think that this is the review. Yeah, I don't have access to. I cannot read. I don't know who I told them, but they told me they will give me access, and they didn't. So
hold on, you don't have access to this
Team
one?
Data Review Trello. I cannot assign myself to issues,
Okay,
because I would like to get tasks on my own. And
let me try to fix it then.
Cool.
I think Alex also had the same issue, right? At first, you couldn't do it.
Yeah, you gave me access and it was good though.
Okay. I forgot
thing
how
is-
I did it. Did I just invite you there?
Maybe. I think so. It was fairly simple.
Yeah, do the invite. That always works.
To just get the invite link. Okay, let me just do it this way. Again, Trello board, like it's every time I'm thinking that we already have everything set up right. We're always run into this housekeeping issues with it.
Yeah, I know, but I mean, that's why people have
Yeah, support
infrastructure
teams.
teams and stuff. Yeah, no, because
Oh, hold
when you
on,
have
it's
a
the
large
wrong link.
organization, okay, this is, I think that you gave me the
So
link.
yeah, I think I hold on. I think I'll give you a wrong one.
Stop sharing.
Hold on, where is it? Team literature review. So regarding like team literature review, we in a sense have two parts of a team at this point, right? We have UX UI action kind of going from that end, so people who are not touching software, right? And now we have this side of the team that touches the code. I think it's definitely reasonable to split essentially whatever, like regarding the code base could be on GitHub projects. I'll definitely support that split, and everything else is on Trello board, so we could kind of tag along what is actually happens on UX UI side of things, because those people I know they prefer Trello for sure.
I mean, I'm okay working with both. In fact, right now I'm using Jira, Trello, and GitHub projects in different things that I'm doing. So I'm already,
Okay.
I'm
Well,
already there.
man, I have so many things open up. Like I have
No, yeah. No, but what
so
I mean is that I don't have preference because I work already with all of them, so I can use Trello, I can use GitHub projects. What I wanted to say is that there is integration. I'm sure that you know with GitHub on Trello.
yeah.
So
I
one of
think you
the
guys
things
did,
that
right?
we
For
can
task
do
view.
is having or issues or allowing them to create issues and track them on their Trello. After when we start integrating right now, I think that we are working as two separate teams. After if they don't give us a definite interface that they are requiring us to implement, we will keep on our work. And when they start asking us, we will see how we do that. But when we have to this point that we are serving data and processes that they are consuming, I'm sure that will arise a lot of problems that I need this modification or this other.
Mhm.
So we can connect our board to their board and there will be no problem. So it's fine. That's what I was trying to.
Okay, so again, right now I mean, I don't like right now. I think the move by Matan, I'm seconding his move to just let's use GitHub projects to create whatever we need here.
It just seemed easier to communicate on the actual code base.
Yes, yeah, exactly. So it's like on abstract level, there's like this separation, the kitchen, and then the servicing of clients at the restaurant, and then we just have an interface between those. So I think it
Okay.
would be useful. I have
Then
another. Do you
if
guys
we
have
are on
other
GitHub,
housekeeping questions?
No, I think this has been productive. This has been helpful to me. So
Okay.
I'm good.
So Manuel, what was your?
no, it's just because I'm on the projects of GitHub and I don't know how to. Okay, I need how to add an issue. Okay, I need to open an issue from here or how to convert to issue. No, I see. Okay.
I'm also kind of
Yeah,
not
it's
very
easy.
experienced using that, but so far I think the workflow is because GitHub first was always right. Issues created essentially as a bug report or something, etc. But so you need to use like to have that as a basis for creating everything else on top of it regarding project management.
Okay, perfect. No, now I'm assigned. Now I can see it. So now I took on. I mean, I put it on the risk factor ingram model. I will ask you for it. I will try to. I will look on the original notebook because all these are working on the Christine Chen notebook
Mhm.
from the submission one, right?
Is it submission one or?
I mean, it's Christine Chen notebook. Everything is from the notebook that Christine Chen presented. So I think that
Yeah.
is there. I just go look and take. I will update the change that we discussed during. Well, here is. Oh yeah, it's Friday. Sorry, because
Yeah.
I've been 10 days working nonstop, and I was not aware the.
Mhm.
Oh, so who? Eh? Yeah. What is Kevin Lee? Open me. Why? Ah,
So
okay,
what's
okay.
going on?
No, that I just get myself on the issue, and Kevin write me on a Slack like, I saw you create an issue on my code in Git, and I say like, hey. I said no, just to reach if I have questions. Okay,
Mhm.
so sorry, I lost.
Okay, so regarding essentially with, I think we kind of got this housekeeping issue. I have other few questions to discuss. So one of them, since we touched this topic of, putting requirements, TXT, etc. So right now, because I know Matan was playing with in his like local environment, I myself always constantly do that, and I'm trying to unify everything between my like local desktop or virtual machine in the cloud, and etc. And I would like to ask you regarding what do you use, for example, for package management? Conda versus pip, Python
Me,
versions, etc. I
I
mean,
I
for
use
everybody on this call, and for you, Manuel, as well as like your experience dealing with
what
virtual environments.
yeah, what I do is usually I use pip and a virtual M wrapper that allows me to create virtual M's and assign the mounting point. So when I change the virtual M, I go directly to the folder so I can switch
Mm.
projects and
What are
handle
your opinion on like Conda and Conda environments?
Conda and Conda environments is a wrapper around the virtual env. That is the
Yes.
real thing that creates a virtual environment. As virtual env wrapper is another one. I think that Conda is neat in the terms that it handles all on the same thing. But when I start working more with packages, as pip is the official
Mm-hmm.
I
Repo.
use it because it was like sometimes I got in trouble because with Conda it worked and with pip it crashed
Mm-hmm.
and then I start use it only pip because of that. But I don't have a strong preference and I can switch without problem.
So
The
by
virtual
default, you optimize for pip integration with other packages and and stuff like this.
what I do is standard Python packages.
Mm-hmm. Okay.
I mean, pip is the the Python packager that the Python Foundation maintains. Okay,
Yeah, yeah.
but beyond the standard library, there are not how to say that real official
Yes,
nothing for
exactly.
Python. You can
It's a
use
Wild
whatever you
West.
want. So
Exactly.
is a
Yeah, that's what I'm exactly like talking about this because there are
yeah, but I
like.
mean, Conda should work as good as pip, but there are
Mm,
some error handling that Conda makes underneath the hood. Okay,
mm-hmm.
some I don't know if they still doing, but there are something like now with the pip check and the pip m, I haven't checked it because maybe it's 3 years since the last time I used Conda, but
Mm-hmm.
they check for inconsistency or with your environment and stuff like that. That pip will crash if you put some requirements, but Conda will handle it and will fix it. So you install a
Mm-hmm.
package with Conda and Conda says it's fine, but you go with pip and pip says, hey, what are you doing? These requirements are not compatible or
Mm-hmm.
and stuff like this. So in these terms I prefer pip because as it's the lower level,
Mm-hmm.
you know that is more reliable, but I have no problem with Conda, not
Yes.
nor PyM either.
What about you guys, Alex and Matan? What do you guys use for package management, etc.?
So I'm using
Mostly pip.
most of that. So when I'm trying to think of like what the end goal here, or trying to understand like so right now when I set up my WSL, I used mini conda to set up the environment, but I'll use pip to install different smaller packages. But is your question geared toward like eventually how we're going to package it and distribute it, right? Or just
well, my motivation here is just like to unify the experience for everybody.
yeah.
Because if for example one person on the team kind of uses, I use pip install our requirements, and then another person is saying like, oh, wait a second, I usually run conda install on that stuff, and it will be exactly what Manuel just described. His experience is just, conda could install everything, no issues there, and everything is fine. You just go along. But another person will like, wait a second, I have all of these warnings, I have this severe warnings, and and it actually broken built on that level. And
what I will try to use is always the most vanilla thing. I mean, if I get, the virtual wrapper, for example, for me is super useful because I got some scripts that run on it, so I can generate it and change them to make sure, for example, when you are working with packaging and different Python versions, that you are that everything is in place and stuff like that. But for me, the gold pattern is always the low implementation for the official. I mean, with virtual M raw vanilla, it works and it crashes with virtual M wrappers, then it's some problem with the guy from virtual M wrapper. I mean, I'm sorry for the user, but it's not like that. So I'm using a higher level, but I think that the standard to what we consider fail or not should be the lower level implementation.
I agree on that.
C Python and virtual.
Another motivation. Go ahead.
I mean, the thing is that it's good when you mentioned that we have the same environment. I told you about, for example, this that I show you about the make files. On most projects that I work, I use a cookie cutter to have all these niceties already set in place. And for example, I always on all my projects, I have make test, make lint to run linters, to run test. So this is something I like a lot of this standardization of the way of working. But in the end, as long as we have clear what are the parameters for deployment or that we support. I mean, if we say we allow you to run us on Python 3738, but not 36 or 39, because 39 is too new for us. We haven't checked it, and 36 is gonna be replaced next year, so we don't take the effort. The thing is that after we agree on that, if I want to code because on my machine I have just installed a new version of an iOS and I don't have that Python version, well, that's my problem. As long as we agree that the versions that we have to support are 3738. If I want to run it in 3.5 to see what it happens, well, if you want to develop like this, it's your problem. The thing is that we are able to tell the people, if you run it in this way, it will work. What we do at ourselves at home or for developing, I think that it should be a little like a personal preference.
Yeah.
Feel free to use Conda, feel free to use pip. It should work. I explained why I do it that way, but unless there are bugs, everyone should do as they feel.
Yeah. And another motivation behind, for example, like for me, kind of to make this decision, Conda versus pip, is if you so what are the the difference from my point of view between like Conda and pip? So pip is it's more low level, more general, more in terms of like kind of support of and maintenance of this kind of interdependency between packages. And for Conda, they are, again, they appear native in terms of what they want to support and how they want to support it. And from data science perspective, Conda right now is kind of popular because if you want to install something like TensorFlow or like PyTorch that needs GPU support, well, right now pip already also up to speed with everything regarding, let's say you just install TensorFlow GPU. If you want GPU, like everything compiled for GPU support. But just a couple of years ago, there was like huge kind of debacle in terms of what to use, and everybody was running into issues when you install everything, but nothing used like CUDA, for example, not the CUDA version, but CPU versions of runtimes. So that's why like Conda got a lot of popularity between data scientists. So a lot of tutorials when you find there will be like, oh, you know, do Conda install of that thing versus pip install and stuff like this.
I think we're all mostly using pip. Maybe I should clarify. Like I installed Miniconda or Anaconda just to get like a global environment up and running. But then to install packages, I'll use 9 times out of 10 I'll use pip.
Well, there's like I'm the person who uses Conda a lot. That's why.
Oh, okay.
And I'm kind of the guy who will be like, I'm first searching the packages on Conda first because I kind of like, oh, those guys probably already did everything for GPU, blah, blah, blah. So I don't need to kind of jump into the rest. That's why I'm trying to figure it out, like, you know, what's up. But since, again, it's like the state of the whole landscape of this space, because all of the examples, let's say on Google Colab, when you look for it, it's all pip install, right? And everybody's supposed to run Colab for like TPU or something support. So hence why I think it only works because Colab instance comes with a lot of stuff pre-installed that's supposed to utilize either GPU backend or TPU backend. But otherwise, like all of those examples you find for collabs, they are not kind of optimal if you actually try to, let's say, run them on your own desktop machine with GPU. And you will run into issues when you're trying to install all the dependencies and then nothing utilizes GPU, or at least, you know, you don't have that speed that you expect. So that's why I'm kind of like very cautionate about, you know, this type of stuff. But anyways, it's
the thing is,
besides our point.
No,
I think
what you say is true, Anton. What you say is true, but there are two little details. First one is what I'm saying is if we make sure that we are compatible with the low-level tool, in this case pip, Conda should follow through, because if it doesn't crash on pip, Conda won't crash on its own. The problem is when Conda hides the error from pip, because Conda knows that there is something that he can solve and it solves, but pip simply tells you, hey, there is an error, fix yourself, because it's lower level. So the thing is if we make sure that it runs on pip, on Conda there should be absolutely no issue. And what we are talking about running on Colab, that I agree that, for example, stuff like this, most people will run it on Colab. The thing is that if we do a valid packaging with valid versioning that you can use for Conda, because this is what they call the package extensions. That is when you put on the bracket squares the name. Like, for example, if you can make pip install pandas and we'll install the regular pandas. You can put install pandas and in bracket square dep or examples, or they have like multiple versions that do pandas and more stuff. And for example, TensorFlow, you can install TensorFlow CPU, GPU, TPU, because they are for the servers. And so this is done on the setup py level. So there is, it should be no problem if we are able to have a valid Python package to run on Colab. The problem is the other way around. When we have some code that, yeah, we managed to run it on Colab. Okay, can you make a Python package of it? And this is where we are now. So the other way around, I'm not worried at all. There is a way. We make a package that we know that if we run it on local, it will run on Google Colab. Is the other way around there is a problem.
Yeah. Okay. So to summarize this kind of side tracking into Conda versus pip debacle, etc. We do everything for pip, right?
Yeah.
And everything should be good to go. In terms of managing environments, again, so what Conda uses behind the scenes? Virtual environment, right? VNV or
VNV. And virtual and wrapper, it uses VNV also under the hood. I mean, because it's a low-level implementation. If I create now a pip M, that is now the new boost, because it handles the environments, the versioning, and the requirements. Under the hood is just wrapping around VM and pip. Because you are not going to re-implement the pip functionality. You're going to use it from pip that is already on the 20th version.
Yeah. Well, I personally use, right now extensively, mostly Conda environments for everything I do, like locally on my machine, just because it's definitely like what is called kind of like sandboxing all of the environment really well in terms of like the commands are short and then encapsulate all of that other stuff on top. So again, great wrapper on top of that thing. But yeah, I think from my end, then I'm good to go. All of my main questions were covered.
Any question that is left, Dubs?
Nothing right now.
None on my end.
Okay, for anything, if you want, I mean, I will be opening pull requests with the, I will update the pull request and with the new things. And please feel free to ask anything that you see me doing that maybe you don't think it's correct or you understand why I do it. Feel free to post any question that you have, okay?
Oh, are we going to work off of continuing the current master branch or the
I'm opening a pull request, so the changes that I make on the refactor branch will be moved to master. But first, before moving them, we are in this evaluation process. That, for example, you put that comment, I realized that there was something missing. I want to check it using the Mongo, and when we are good to go, then we put it to master. And also, I don't know if you're familiar with the GitHub workflow.
Yeah.
I mean, you can have multiple pull request opens at the same time,
Yeah.
especially in a project like ours, that we are not overstepping each other because we are different branches from the same tree.
Right. Yes. I got it.
Yeah, one thing about Git flow or GitHub flow, because Git flow is totally different anyway. So GitHub flow, again, one of the principles to follow there, don't make your branch like long, right? It's like it should be short and very similar to the principle of like the functions should be like small, doing one thing. The same thing is like the branch you do is, so you do frequent pull from master, update whatever you work on that branch, and then the moment then it's done, you do pull PR request for pull request back to master, boom. And so the most simple approach, it works. The only like the main issues arise only when you do like this really long branch. I mean your branch you're working on. If
and
you
do you usually, when you do a commit, let's say you have 3 files to commit, will you do it in one push or in 3 of them so that you can comment?
Look, that this doesn't matter.
Doesn't. Okay.
And I explain you how the number of commits, it doesn't matter. It makes sense what I say about the correspondence between the processing the code and the abstractions that we are trying to make. For example, let me share quickly my screen. Share screen. Yeah. Share. You should be seeing my terminal.
Yeah.
This is, for example, a git log. Okay.
Yeah.
This was because I was doing the organization of the package, but some of the things that were here were done at the same time, but they were conceptual different things. One thing is dropping support for Python 3.35. Another thing is fixing that the build was crashing. Another thing is what there were missing dependencies. You know, even if I was changing the same 2 files, but any of these changes were for different scopes. So when I go to Git, then I can see only the changes that affect that. If I put them all together in one single commit, or if I mix things that makes no sense, then is when it's hard to track also.
So Manuel, do you have TIG installed? Can you try TIG? TIG. So Git, but reverse.
TIG, never heard of that.
So try it out. It's a really awesome tool I recently discovered like a month ago, I was told. Usually it gets bundled with a lot of Git installations when you do. So instead of Git log, just try TIG. Let me seller. The TIG.
Oh, it's like a Git extension.
So it's a tool to navigate the history, commit history.
That's super cool. Like the visual things, the visual clients that sometimes there are. Yeah, I'm looking at. I'm looking at the manual.
But you can do stuff like that in
so try it out.
Right.
So try it out. No, yeah, exactly. But I mean, like all of those. I mean, it like here it just. Before I was usually using Git log, like one-liner.
This is Yeah.
awesome, right? So
But
I
then,
was
for example, here you
showing
see
it
that
like, yeah.
this was on setup.py, 4 lines change. Yeah. This was also on GitHub Actions. And yeah, this was only on GitHub Actions. This was something on setup.py also. But I split the changes on different commits. So the different actions that make sense on themselves were separated. If I make a commit that it says bunch of stuff, and I make changes to 25 files, it's easier. But the moment I have one problem and I need to roll back one commit, I also need to roll back a lot of things. And if I need to understand all the changes that I bring a lot of changes at the same time. If you see this commit that you say, but it's only 2 lines, yeah, but it's clear to understand. What are you doing here? I'm putting support to matplotlib in this range of values. Nobody has any doubt about that because there are only 4 lines, and it's clear with add missing dependencies. Always there is one idea, okay, that the people who, maybe it's easier when you are doing rocket science, no? But the guys at the NASA and the people at SpaceX and people who do things that fly and go quite fast, they always tend to think like the normal case is the worst case scenario, and everything is a Git from code. So when you code, when you do this stuff, don't code it thinking in the happy ending that everything is gonna be fine. Nobody is gonna ever run this test in an environment where it can crash and lose lots of money, and the responsible will be me or something like this. You think, oh, I'm at home happy. No, think like, oh my God, what tools and what preparation do I have if this sets on fire? If I've got this launched on production and is that like a paid service, like it's your job, and you say, and this crashes, you cannot say I have nothing in place. That's why you have version control, that's why you have branching, that's why you have testing and continuous integration, that's why you have a test environment, that's why you have backups and deployment on multiple cloud services, that's why you have all this infrastructure, thinking like, what if this concrete part goes wrong, and have a plan B for that. So having the commits organized like this is a plan B when you are seeing the changes that you are done in a deployment, or you are doing in a versioning of a library, or any kind of software, that you can see it in small pieces that you can understand and you can follow. And this is maybe it's not very useful right now because you can take the time, but you don't have to think that how is good or bad right now, because it doesn't matter. Because what you need to do is the moment that it crashes and is a critical crash, and in a moment that I need to fix it right now because I'm working against the clock. Imagine like with an axe wielding craze behind you. Then I need to go fast. Then I need to not make mistakes. Then I need all the things that I can make to make sure that everything is on place fast. And this is when these things come in place. So most of the things now doesn't seem to have a reason to say, oh, Manuel says that it's easier to have one commit with 3 lines because then you see the other dependencies. But oh, I can see that there are the dependencies. You can see them when there are only one file. If I show you where it was, this one, all the changes that I have, I don't know now, how can I? Yeah. If I tell you to try to understand what I have done here, that you see that I'm deleting half of the file and then I'm rewriting the functions with another names and another parameter, you cannot. I cannot. Nobody can. That's why, for example, this is because I was doing something that I know that I was only copy and pasting and was doing no real changing, only reorganizing the modules. But if there was some change of code, the fact that I'm moving these large blocks and that I have like how many lines, I don't remember how many lines they were, but how I move here. Okay, organize packet. I don't know how to go. Enter. Okay, it's back. This is back. How to? I cannot.
What are you trying to do?
Cool. Yeah. Okay. No. Now I see. Now I see. I need to go like this. Okay. So the thing is that if I don't know how many lines I have changed here, but maybe there were a few hundred. if there were actual changes of code instead of moving unmarked things and uncommenting lines, these were 580 lines added, 550. This is not acceptable, for example, as a commit, unless this is something like this, that I'm moving functions from one file to another, and then this will happen. But in a normal case, to track if there are changes also here, this is a mess. This is impossible. You need to prepare everything like to be able to be understood when there is a problem, where is a crash.
Actually, even you don't even need to go to this like really edge worst case. After a couple of merging conflicts resolution, if you do it like in practice, you'll quickly learn like what size of your commit should be there in terms of balancing it. The smaller they are, the easier it's to solve all of the merging rebasing conflicts. And then you'll be kind of like, that's why I'm doing it in the small chunks.
100% agree that once we have a hellish merge conflict, you start to try to make the small pull request that you can always. Also, there is one way, I don't remember when I read it, but there is one way like you can make split pull requests, like doing separate branches based one on the later. Like I start from master and I create branch 1. I make my changes. After I finish, I create a new branch from branch 1, not from master. And I make the second part of the changes. Then I create part 3, part 4, part 5. When I'm on the branch 5, I have 4 different branches with 4 closed steps of the process that I can make 5 pull requests that are easier to review also.
Okay.
There are ways, but the thing is also what I was saying about control and clarity and knowing what is happening. Not in the terms that you are looking physically at the electrons on the memory, but knowing that you say, okay, I call Python with this file that should just load a CSV file that is 3 rows. It should be fast. No, I'm gonna download 100 gigabytes. Oh, this should take a while. At least I can make an idea of how much it will take, what we'll be doing. Then having this having control version and use it wisely helps you a lot to understand how the software has been developed, what functionalities, because sometimes you find code that you say, why this is written this way, why this function is so ugly, because sometimes somebody make it was good, then they added some functionality to integrate with something, then this something was deprecated but it wasn't deleted on the function. And when you have a big project, sometimes this happens, that you have one function that there were 10 lines, but now are 150. And maybe from that, there are 30 that are never used or are deprecated or are directly buggy. And you can only find these things if you have proper control versioning.
Yeah.
Well, I think that we're going to leave it here for now because
2 hour
I'm starting to feel for the moment like an old man ranting at the clouds. I think that basically the ideas that you need to have when working with Python, that were these 3 no unexpected things, and that means do what you are asked to do and not doing what you are not asked to do. About terms of imports and lag, and this first concept, the correspondence between ideas and abstractions, and the third one, that separate the things so you are able to articulate different interfaces, like offering the same product, like McDonald's, in different ways. The hamburger is the same, but you can order and receive it in multiple ways. So these 3 ideas are the things that you need to keep in mind, and the rest is just practice.
Okay, beautiful.
Yeah, it's helpful. Thanks, guys.
Thanks.
All right, Anton, I'll send you a link, or I'll share it with all you guys once.
The video will upload it somewhere.
Gentlemen, thank you very much for your time, and Manuel, thank you very much.
Okay.
Have a good weekend.
Have a good weekend.
Bye.
Bye.
See ya.
Thanks, everyone. Bye.
Bye.